Welcome to the last pre-calculus video. Last week we ended up finishing chapter 12 with our quizzes and we did pretty well. And here we got chapter 11. Now, reminder that everything from this week will be due on Friday, May 1st, because the week after, May 4th through the 8th, will just be a catch-up day for those of you who have work to do, and we won't have anything because we've got everything done now. Now you might be concerned because there's only one video over chapter 11, and if you were to thumb through your book, chapter 11 has 7 sections. Does that mean we're going to do 7 sections in this video? No. Unfortunately, a lot of the chapter, basically probably 75 to 80%, is supposed to be done on a TI-84 or a TI-Inspired, and I can't know for sure if you guys have all those. I know a lot of you like those basic ones, those ones that are just easy to work with. So I will focus on teaching you what I can from the chapter. That all being said, most of it should be review just because it's based off of some geometry we did way back 2 years ago in chapter 13 where we covered a lot of the same statistics. Okay. So chapter 11, inferential statistics. Okay. So we're going to jump right into 11-2. Which is all about probability distributions. So the first thing in chapter 11-2 are 2 types of variables. We have discrete variables and then we also have continuous variables. Discrete variables can only be whole numbers. For example, number of chairs in the room. You can't have half a chair. And I know someone's going to make a comment, what if I just chopped off 2 of the chair's legs? No. Only half the chair. Or only whole number chairs. Continuous variables can include decimals. For example, let's see, we could have ounces of water. For example, if I'm drinking my water, am I always going to have the exact 32 ounces? No, that'd be cool if the water continuously refilled, but it doesn't. I could have 13.7 ounces, etc. I could have a decimal for that value. Do I have to? No, but I could include those decimal values. So let's do an example. Example 1, discrete or continuous. A, weight of a 15-ounce cereal box. Taking at a random time, this one would naturally be continuous. I'm going to trick you by saying a 15-ounce thing, but does it weigh exactly 15 ounces? It might not. It could, in theory, weigh 15.1, or let's say you just went to town on a Cinnamon Toast Crunch or whatever, what have you, and it weighs a little less, something like that. But it could include a decimal place, so we have to consider that a continuous. Or B, the number of cars in the parking lot. Now this one would, again, naturally be discrete. We're not going to consider someone having an extra engine in the back of their car or the back of their pickup a percentage of a car. It's either a car or it isn't, so we'd only have whole number values for those cars. Okay, moving on. Oh, sorry. We're still in 11-2, my fault. Now we're going to talk about probability distribution. Probability distribution is just the probability of each outcome. Okay. Well, first we need to remember what probability is. Well, probability is, everybody just our outcome over our total. So it'll make more sense if we just jump right into the example, I believe. So example 2. Let's say students with pets, so pets and students. Okay, let's see, 1, 2, 3, 4, 5. And what did the book do? Okay, one student has 1 pet, we have 8 with 2 pets, we have 20 with 3 pets, we have 16 with 4, and then we have 5 with 5. Okay. So, a probability distribution would just be a third category. So, I guess I can put it right here. Probability distribution. So, I need to find the probability of each possible outcome. That being said, I'm going to need a total. I'm going to need my total number of students. So I encourage you to write a total down here. Total. Now total is pretty easy. We just add them all together. 1 plus 8 is 9. Plus 20 would be 29. Plus 16 would be 29. Plus 6 would be 35. Plus 10 would be 45. Plus 5, so our total is 50. Okay. So what is the probability of I pick a student with 1 pet? That would just be my outcome over my total. So 1 over 50 or 0.02 or 2%. Okay, what's the probability I pick a student with 2 pets? Well, that would be 8 over 50 or 0.16 or 16%. What's the probability I pick a student with 3? That would be 20 over 50, or 0.4, or 40%. What's the probability I pick a student with 4 pets? 16 over 50, or 0.32, or 32%. And then 5, I get 5 over 50, or 0.1, or 10%. Now the best way to double check this is I could just add all these together, because again I have to have a total. I have to have a total of 100%, because something has to happen, right? So I get 2 plus 16 is 18, plus 40 would be 58, plus 32 would be 58, plus 32 would be 90, plus 10 would be 100%, so I know I did it right. So probability distribution is just the distribution, it's the distribution of probabilities. Just probability of each category, and you were to distribute it evenly. Okay. And then we get one more thing in 11-2, which, again, this is something we did in geometry, and the next thing is we're going to do something we did in geometry as well. It's called expected value. Expected value takes your, a value of, let's see, where's my official thing I had for it? It's value times probability, and it's probability, and it's the sums of those, if you have multiple. So the example we did way back when in geometry was the expected value of rolling 1 dice. Well, I could roll a 1, and what is the, that'd be my value, and what's the probability I roll a 1? Will that be 1 in 6? I could also roll a 2, and the value would, or the probability would be again 1 in 6. I could roll 3, which would have a 1 in 6 chance. I could roll a 4, which is a 1 and 6. I could roll a 5, which is a 1 and 6. And I could roll a 6, which is, again, still a 1 and 6. Now the thing is, for expected value, you have to find the sums. So at the end, you have to add them all together. Okay? So I get 1 times 1/6, which would be, again, 1/6. You get 2 times 1/6, which would be 2/6. You could reduce it to 1/3. I'm going to keep it like that because I'm going to add them all at the end, right? So I want common denominators so they're easier to combine. I get 3 times 1/6, which would be 3/6. I get 4 times 1/6, which would be 4/6. And I get 5 times 1/6, which would be 5/6. 6 times 1/6, so 6/6. And I can just add them all together. Okay. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 would be 21. So I get 21 over 6, or 3.5. So my expected value would be 3.5 rolling on a dice. This is often used to make decisions and other sort of things, not just in like say Dungeons and Dragons, for example. It's an easy one because dice, but also people who make decisions often calculate this things through probability. That's why if you ever turn on ESPN and it says something like a three-pointer is better than a long two for basketball, it's because the expected probability gives you more points in theory. Or when they say you should go for it on 4th and 1 given a situation, it's because the expected value of you winning the game is just more likely. That's where all that math kicks into those sports. So if you ever hear anything like that on ESPN or a commentator saying you should go for it 4th and 1, odds are you should, or something like that, this is what they're talking about. They're doing expected values. Okay, so let's do an example. Okay. This would be something like example 5. I made a quick one just because I didn't want to take so much time. So expected value. But if you wanted to go through a more in-depth one, that's fine. So let's say you're playing a video game and you have an 80% probability chance of winning 1,000 points. Pretty good. But you have a 20% chance of losing 25,000 points. Okay. What do? Well, you would just do the expected value and see if it would be profitable for you in theory, in the long run, right? So my value would be 1,000 times the probability that I would get 1,000, so 0.8. Make sure to convert that to decimal. Plus my negative 25,000 because it says losing points, and I would multiply that by the probability, so 0.2. So I would get, let's see, where'd my calculator go? 1,000 times 0.8 would be 800. And then I get 0.2 times negative 25,000, which would be negative 5,000. So my expected value would be negative 4,200. So the reason is, should I make the gamble? No, I shouldn't. And in fact, this is not as extreme because typically in a casino it'd be a little different. But this is what casinos do all the time. They try to figure out expected values to where a person should, theoretically, in the long run, lose because casino doesn't want to give out money. So expected value comes up a ton in the real world. Okay. All right. That being said, we're going to jump all the way to 11-6, and we're going to talk about one more thing because again, everything else is honestly done in the calculator, and a lot of t-testing and stuff like that. And not much else I can really do for it. Okay. So 11-6 is called hypothesis testing. So if any of you guys go on to do statistics in college, stuff like this. So first it's going to have two different types of hypotheses. You're going to have hypotheses. You're going to have the null, and you're also going to have the alternative. So the big thing is the null is going to be represented as h sub 0, and this includes your less than or equal to, greater than or equal to, or your equal sign. Your null hypothesis will always be those things. Your alternative will be h sub a, and it only includes greater than or less than. Okay. So if you have a term that could include a test value, that's always going to be your null hypothesis. Now, often you'll have to talk about what's the claim. You'll have to identify that. It could be either. It has to be based on the statement. So, that being said, let's get into an example. Or a couple. Again, this is 11-6, example 1. Let's see. A gum brand, claims flavor will last at least 5 hours. It claims if you chew on that gum for at least 5 hours, to still have flavor. Okay? So first, we need to identify what the expression's been saying. Well, first we got our test value, 5. And the big thing is we need to look at this at least value. So the question is, would at least include 5 hours? Is 5 hours at least 5 hours? In this case, yes. So the claim is at least 5 hours. So, and this would be an at least, so it would be greater than or equal to expression, right? So greater than or equal to is my null. So I would get h sub 0 has to be at least 5 hours. Okay. Now my alternative is everything else. So my alternative, if the null is 5 hours or more, the alternative would be less than 5 hours. The null hypothesis and the alternative hypothesis work in conjunction together. Now the last thing we identify is the claim. The gum brand claims this, so in this case, is the null or the alternative my claim? This one would be my null. Okay. Now let's do another one. Let's see. Okay. A car company claims it does oil changes less than 15 minutes. Okay. So again, do I have a test value? Yes, I would have that edge would just be that 15-minute mark. Now, I need to look at the words leading up to it, in this case, less than. Now, does less than include 15 as a value? Is 15 less than 15? No, it's not. So I know that my marker would be something like this. Well, does this have an equal to sign value attached to it? No. So it has to be my alternative hypothesis. It would be less than 15 minutes. And then just inversely, my null hypothesis has to be everything else. So my null would be everything other than less than 15 minutes, which would be greater than or equal to 15 minutes. Okay. So remember, my null will be less than or equal to, greater than or equal to, less than or equal to, or equal to. And my alternative will be less than, greater than, or technically it could be not equal to. Let's do an example with that, might as well. I'm going erase all these here a sec, so. Let's see. Let's see. Michael claims he will score exactly 61 versus the Celtics. Those of you who don't know, 61 is the highest ever playoff point total, and Michael being obviously Michael Jordan. Okay, so the claim would be exactly 61. My 61 would be my test value, exactly meaning an equal sign. So with an equal sign, it would be my null hypothesis, h sub 0 colon equals 61. My alternative would be everything else. So I could write h sub a is less than 61 or greater than 61. I'm sorry, greater than 61 or less than 61. The easiest way to say that would just be not 61. And then last but not least, we have to identify the claim. In this case, it would be h sub 0. And the last one, I forget if we identified the claim with the oil change. The claim would naturally be the alternative hypothesis, because that's where we built the other one from. So we get claim h sub o, h sub a, h sub o. Okay. Otherwise, that's it for the book for stuff I can teach you. It's been a great year, and hope you guys have a good one, and I'll miss you. Have a good day.